Hello my dear students, now we will go through to the convolution of the solved examples. So there is a convolution, as you can see. Find the convolution of the signals u t minus 1 and u t minus 2. The given signals of u t minus 1 and u t minus 2, their convolution can be done as shown. That is the convolution that we are going to learn about. That is yt is equal to u t minus 1 convolution of u t minus 2. And the convolution theory, as you can see here, there is the integration of ut minus 1 into ut minus 2 dt, and after integration we will get rt minus 1 rt minus 2, these two functions, and it will be totally delayed function. As you know, the property of convolution, that total delay will be added here. So t minus 1 plus 2 is equal to t minus 3. And find the convolution of two signals that are given here. There are first signal, this is the signal of sequence, okay, and this sequence is shown as a set of numbers 3 comma minus 2 comma 2, and the second sequence, there you can see that is a mathematical expression, okay. So first of all we have to just decode these signals into the set value. As you can see that the four sequences are equal to 0 to 4. That means there are 5 sequences of 0 to 4, 5 indexes 0, 1, 2, 3, 4, and all the value are 2, and elsewhere in any type of value that will be 0. So we can write as 5 2, that is 2 2 2 2 2, that is a 5 2 2 comma 2 comma 2, and that has been decoded in the x2n sequence. In the previously given sequence, that is x1n, that is 3 comma minus 2 comma 3. So it can be jet transformed. It can be jet transformed, as we can see that if you want to transform this sequence, that is the origin. If there no origin of arrow is shown there, we will have to take the first element as its origin. In that particular section, the origin will be 3 into z to the power 0 of the indexes value. As we know, the jet transform, that is the summation of xn z to the power minus n, okay. So it is 1, so z to the power minus 1, that is that will be again 3, sorry, that will be 2 here. So that here is also 2, so 2z minus 2. So that will be the first sequence, that will be jet transform. Then again take the jet transformation of x2n as 2 z 2 to the power zn minus 1, 2 to the power z minus 2, plus 2 to the power z minus 10, 2 to the power z minus 4. That is the constant 5 sequences from 0 to 4. Now the resultant signal will be the multiplication of the jet transforms. Just very easy in the convolution sector. We have to just jet transform both the signals and then just multiply it, because that is the theorem of convolution, that is the convolution theorem. Just convert the time domain sequence to the frequency domain system, that we have used the jet transform here. Just after that we have to just multiply algebraically. As you can see here, after multiplication we just multiply these two parts, and as you know, this multiplication, how can you perform? First of all, multiply 3 with all of the values, then 2 minus 2 to the power z minus 1, all of the values, and then plus 2 to the power z minus 2 to all of the whole values, and you get, after calculation you get this. So there is a lot of calculations right there, okay. Now you get the sequence right there, and whether there is no z, that is the origin. So that will be 6, 2. So these values are the value of the elements 6, 6, 6 and 6. Okay. So taking inverse jet transform of the above, we get the resultant signal as like that: 6, 2, 6, 6, 6, 0, 4. Origin at the first. So that is the origin at the first. I think there will be a lot of other sequences that might have to be added there. Then we'll get the 0, 4 or else that has been written there, but we have to first of all find it out. Now in the example 3, there is one thing. As you can see in example 3 solution, there are two sequences xn and hn. As you can see, there are two signals xn and hn, and they are in the set method 2101 and 1231. Okay, so first of all we have to make it the jet transform. We get the 2 plus 2 to the power j to the minus 1 j to the minus 3, and then hn 1 plus 2 j to the minus 1 to 3 j to the minus 2 and 3 j and plus j to the minus 3. And after that we have to just multiply both. After multiplication we get the value like that, that is 2 plus 5 j to the minus 1, 8 j, plus 8 j to the minus 2, 6 j to the minus 3, plus 3 j to the power minus 4, plus 3 j to the minus 5, and j to the power minus 6. As we know, after taking inverse jet transform, all the jet will be get out from here, and it will be a sequence of a set, and the coefficient of the jet will be the value of the element 258661, that is the original first, as the first value lies no jet here. So that's the solve examples of the convolution theorem. I hope you will understand it very clearly. First of all, you have to take the jet transform, then you have to multiply it, and if we want to decode each of the sequences, if we can decode each of the sequences from the functional value to the set value, then we can easily find out the convolution of any kind of sequence. Thank you very much for being with me.